Hi there, my name is Jolt, and in the next few minutes I will give you a quick overview of some of our ongoing work. Most of the big data computation in the cloud happens in a multi-layered setup. And even though this has many benefits, it also introduces data movement bottlenecks. We have known for a long while that pushing down computation to the storage nodes can actually alleviate these bottlenecks. And today we live in an exciting time where solutions built around this idea are appearing in practice. In the cloud, such as the Amazon Aqua solution, in commodity hardware such as the Samsung Smart SSDs, and appliances such as the PlyOps computational storage. Most of the systems that I mentioned came to be as a result of decades worth of research on how to make processing inside the storage happen with high performance and high efficiency. Moving forward, however, I think there is an imperative to look at other types of challenges such as privacy. And indeed, what we're doing in our ongoing work is looking into ways in which we can offer system support for enforcing privacy rules inside the distributed storage layer. More specifically, we're looking at ways of monitoring and transforming data. And in order to achieve this goal without actually slowing down the application running on top, we're exploring the use of specialized hardware-based smart storage nodes using FPGAs to offer low latency and high predictability privacy-related computation. In the following, I will look at two directions that we are currently exploring in my group. One direction of our work is in collaboration with Sujanya and Vijay from the University of Texas at Austin, and it looks into how we can use smart storage nodes to enforce data protection regulations with minimal overhead. And as you might be all aware, GDPR and similar frameworks incur significant overhead if we cannot actually offload some of these operations to the storage. What we propose is to take a software-defined approach and look at the storage as basically an enforcement layer that doesn't take decisions, and to dedicate the decision-making to a software controller. In some sense, this is similar to software-defined storage, but we look at access and protection instead of performance-related issues. As a result, we can simplify the requirements, the processing requirements inside the nodes, and we can almost achieve today this goal by repurposing existing building blocks in the field. Now I say almost because we are still missing two important puzzle pieces. One is offering trusted execution environments inside the storage node. And if you're interested in why this is actually necessary, please go and read our paper. And the other puzzle piece is how can we efficiently map high-level data regulation to low-level software-defined data protection rules. To tee up the second direction of our ongoing work, let's take a look at the simplified view of a data processing pipeline. As you can see, the first step is data retrieval, which of course maps to the storage node. And then the second step is the actual query computation. And this can either map to the compute nodes, or in the case of a smart storage solution, can be partially or entirely offloaded to the smart storage node. In contrast, if we look at the data processing pipeline, where we have to carry out privacy-preserving operations, or perturbations to be more specific, between data retrieval and query processing, or after the query processing, what happens is that since these perturbations can typically only be executed inside the compute nodes, the smart storage might become unfeasible for query offload. So what we're advocating for in our ongoing work is to explore ways in which we can actually offload perturbations to the smart storage, and through this, keep it relevant for future workloads. With colleagues from the Technical University of Cluj-Napoca, we have implemented two off-the-shelf algorithms inside Smart Storage Node to understand the trade-offs and future challenges of providing privacy-preserving perturbations. And one algorithm is performing randomized 3D rotations on the data that hides personal information, but still allows one to train some types of classifiers on the data, and this way retains some utility. The other algorithm is differential privacy that we apply inside the storage on top of histograms and group by aggregates computed also inside the storage node. What is interesting is that in the first type of algorithm, which happens right after retrieving the data from persistent storage, the main challenges are related to implementing these operations in a way that guarantees line rate. Whereas for the second type of algorithm, because the data set that it works on is smaller than the data that is being retrieved from the storage, its challenges are not so much on the high performance implementation, but more on finding ways of integrating this with the higher level control frameworks available in software. So that was our ongoing work in a nutshell. If you want to discuss further, please feel free to reach out, and thanks for your attention.